Hello, this is Mr. Collier, and today we're going to be solving or finding the intersection of two lines graphically. And we're going to be using our GDC to do that graphically, and we're also going to be using our GDC to find this intersection with polysmol 2. So firstly, let's take a look at a first example. So we're going to find the intersection of these two lines by graphing below. So in the first one, it's already in gradient intercept form, so the slope is 3 out of 1, the y-intercept is -4. So I start at -4, make a point, and then the rise over run is 3 over 1, so I can go up 3, I can go right 1 to get another point, and do the same thing again, up 3, right 1, up 3, right 1, and I'm going to draw a line here now. Perhaps I'll do this one. Okay. So there's my first line. And the second line is not in slope-intercept form. We could find the x-intercepts and graph. Actually, let's do that method. So if y equals 0, we can solve for x. We get 3 times 0 plus x equals 3, and x equals 3. If x equals 0, then 3y equals 3. And we get the y-intercept equals 1. So we have the x-intercept, the y-intercept, 3 and 1, and then we can graph it. So I'm going to actually graph right here. Okay, like so. Now notice it's a bit difficult actually to see where the intercept is, but it looks like it's about right here. It looks like the intercept is, or the intersection point, sorry, is at maybe 1.5, 0.5. So this is one of the flaws of using the graphing method. It's very hard to determine exactly if you graph it by hand. So let's double check with the graphing calculator. Okay, so we're going to graph that now. We're going to go to y equals, and I'm going to type in these equations. So I'm going to type in 3x minus 4. And for the second equation, now you need to solve for y. So I'm going to go back and make sure I solve this equation for y, and then I'll be able to type it into the calculator. So I'm going to take this equation, and I'm going to subtract 3y from both sides, or actually I'm going to subtract x from both sides. So we have 3y equals -x plus 3. Then to solve for y, I divide by 3. So I get y equals, and you can actually just type that into your calculator directly, or you can write -1/3 x plus 3 divided by 3 is 1. So I'm going to do that now. I'm going to type in, let's do it over here, I'm going to type in, actually I can just type in the first part. Let me show you how to do that. You can go to alpha f1, and we can actually get a fraction right here. See, so that was alpha, and the y equals button, or basically that's alpha f1. Press enter there, and I can type in a fraction directly. So I'm going to have negative, use a negative symbol, not the minus, -x plus 3, then down to the denominator, I put in a 3, and now I'm going to graph. So you can see where the intersection point is. It looks like our graph that we did earlier here by hand. If you want to find the exact value of that using your graphing calculator, you have to use the functions under calc. So you go to second function, that selects the blue part, which is calc, and we want to find the intersect. Oops. So we're going to intersect, and actually for the first curve, so right now my cursor is blinking on this line, so I'm going to press enter to select that as my first curve. And just make sure when it says second curve that you're on the other line, and I am on the other line, so I'm going to press enter. And your guess, you're going to try to go as close as possible to the point of intersection. And then press enter. And then it works it out, and yes, we were correct before. It is x equals 1.5, y equals 0.5. That is the intersect. So we just verified that this is correct. That's the intersect. What does this intersection represent? Well, it also represents, besides the point at which the lines meet, it also represents the solution to the simultaneous equations. Okay? So if you were to solve these two equations algebraically, you'd get x equals 1.5 and y equals 0.5. So let's take a look at another example. We're going to find the points of intersection here using our GDC. First one's in slope-intercept form. The second one, we're going to change it to slope-intercept form. Y equals, so I'm going to add 32 to both sides, so 6x plus 32, divide by 2. So everything gets divided by 2, we have 3x. This gets divided by 2, we get 16. So that's what I type into my calculator. So I'm going to clear everything that's already in there. Oops, that's the wrong button. So let me quit that and go back to okay. So clear the second one here, and I'm going to type in these two equations. So half x minus 22, I can do 0.5 x minus 22, and the second one I will have 3x plus 16. 3x plus 16. So I graph those. Now we have one line here and we don't see where the intersection is, so we're going to have to probably change our window settings. Okay, maybe we can actually zoom out. So we zoom out until we actually see it. Okay, so there's actually the point of intersection right there. So now I can use my second function, calc. Go down to intersect. And I'm on the first curve. Okay, that's the one on the bottom there. And then the second one, press enter. Now I'll go as close as possible to the point of intersection. Press enter. So we have negative 15.2 and negative 29.6. That would be almost impossible to do by hand. So we have negative 15.2, comma, and I've forgotten the y value. The y value is negative 29.6. Negative 29.6. So that's the points of intersection. So let me show you another way to do that now, using Polysmalt. So that's a very important program here. Polysmalt 2 is better than the first one. So I go into apps, I get the program. We have root finder, that's for finding the x-intercepts, and we have simultaneous equation solver. So press enter on that. And how many equations do we have? We have 2. How many unknowns? We have 2. We have an x and a y, so that's 2 unknowns. Do we want our answer as fractions or decimals? Well, you can. You usually want your answer as fractions, so actually let's keep it as fractions for now. And don't change any of the other things. That's all fine. We can go to next. That means you press this button right here, and it's got a matrix there. So you have to be careful. You have to make sure that you have put maybe the x coefficients here or the y, doesn't matter, and then the x here and the constant over on the other side. Okay, so right now I've got them in this form. Alright. Well, actually I've got this equation. That's not correct at all either. We need to change them both to general form in order to use Polysmalt. So change this to general form. So I'm going to label this equation 1 and equation 2. So So equation 1 is y equals half x minus 22. If I want to get the x over on the other side, I'm going to subtract half x. So plus y equals negative 22. Now we have it in general form. So the fraction doesn't matter because we can type in the fraction on our calculator. We don't really need it in actual general form where you have to have integers. So the second equation is 2y minus 32 equals 6x. So we want the x over on this side so that we can use our polysmalt too. So we have negative 6x plus 2y, and we're going to take this and move it to this side. So that's negative 32. So now we have x, x, y, y, and then the constants over here. Okay, so we're going to go to polysmalt 2. I want to use this equation with the x, y constant, and this equation with the x, y constant. So I'm going to type in here, maybe negative 0.5. Let's do this one first. Negative 0.5. 1, that's the coefficient of y there, negative 22, and the next one here we have negative 6, and 2, and negative 32. So once we have all that typed in correctly, we can click on solve. And it gives you the fractional answers, which usually you prefer. Actually, if you want to actually have a good idea of what these numbers represent on the graph, you might want decimals. So let's go back. Let's go back to main. Let's enter here. Let's change that to decimals, and we'll see what the decimal answer is. Go to next, and then I can solve. So as you can see, we didn't get the same answers we got before. So obviously, you must have made a mistake. So it's a good way to check your answers too. So let's take a look here. Where did I make my mistake? Right here, I have a minus 32. I brought it to this side, so that became plus 32. So let's go back to the equation. You can go to click on System here, and I will change this to a positive 32, and hopefully we'll get the right answer this time. And we do have the correct answer, so that is correct. So this is correct. We verified it 2 different ways, so it should be correct. Let's take a look at another example here. You and your friends are baking some cakes to fundraise for an 11th grade trip to Vienna. You will face the following costs. So a one-time fee of 15. A one-time fee, that's a constant fee. That's going to likely be your y-intercept. And then you have €1.50 per cake for ingredients. You sell each cake for $5. Determine an equation to describe the cost. So your cost, you're paying $1.50 per cake. Alright, $1.50 per cake, and n, we're using n here instead of x. So $1.50 times the number of cakes, plus that one-time fee of 15, okay, is your equation for the cost. And your revenue, the money you take in, is going to be €5 per cake. So that's just 5n. So we need to graph these two on the equation. Actually, I'm going to use a different color for both of them. So I'm going to graph the cost in green. So I'm going to start with the y-intercept of 15. Okay, and the slope is 1.5. So I'm going up. Now, if I'm going up 1.5 per cake, that means for every 2 cakes, I'm going up 3. So I'm at $15. If I sell 2 cakes, I'll be up to $18. So I'm going to make a point here. If I sell 2 cakes, I'm up to $18 in cost. If I sell 4 cakes, I'm up another 3. I'm up at 21. Sell 2 more cakes, I'm up another 3. I'm at 24. So it goes like that, and you can get a bunch of points. And I'm going to graph that in with a green. Where is that at? Where's my green squiggly line thingy? There to go. Okay, so I'm graphing that one. That's the cost. And then in red, y equals 5, and of course the y-intercept is 0. So 1 cake, I'm going to bring in €5, then €10 for 2 cakes, €3, 15 cakes, €4, 20 cakes, €5, 25 cakes, and so forth. Okay, no, not that one. Let me see. There we go. Let's do this. So that's your revenue. Okay. Alright, so I've graphed the two, and later I think we're going to have a question about the intersect, of course. Okay, the intersect looks like it's going to be at 4.5 cakes and $22. That's where you kind of break even. So let's take a look at the next question. Oh, okay, now we have it actually graphed, and you notice that this one was done electronically. Our previous one, it looked like we had a 4.5 cakes 22. It looks a little bit off. Okay, so the computer one is probably more accurate. So this is the actual intersect right here. So circle the point at which you would break even. So that would be that point. Okay, so what is this point? Calculate it using your GDC. So it looks kind of complicated. We're going to actually calculate it on our GDC to get the exact value. So you can go to, see, let's graph that. So let me just quit and go to y equals. So let's graph the first equation. Well, we had 5x, or 5n. That was your revenue. The cost was €1.5 per cake plus €15 startup cost. Okay, we'll graph that. Okay, you can see the intersection point right there. And we can go to second function, calc, go down to intersect. Okay, I'm going to press enter on the first curve. What happened? Oops, I think I made a mistake here. Let me try it again. Second function, calc, going down to the intersect. Oops. Press enter. Now I'm on the first curve, so I'm going to press enter. I'm on the second curve, enter. My guess, I'm going to go close to the point of intersection, press enter. And there we go. Now, it looks a little bit nasty, but actually they look like sevenths to me. Alright, so let's round these numbers. So that's going to be, actually let me just copy and paste that over here. Okay. So it looks like our point of intersection is going to be about, or approximately 4.3. Let's just use three significant figures. 4.29, 21.4. Okay, so after selling 4.29 cakes, it looks like you break even. So what's the smallest number of cakes you need to sell in order to make a profit? Well, you can't sell 4.29 cakes, so you need to sell 5 cakes in order to make a profit. Okay, so what's the profit you make if you sell 10 cakes? So you have to take your cost, or actually you need to take your revenue and subtract your cost. So you're going to take your revenue at 10 cakes minus your cost for 10 cakes. Okay, so our 10, your revenue is going to be 5 times 10, which equals 50. You make €50 for 10 cakes. Your cost at 10 cakes is 1.5 times 10 plus 15, which equals, actually 15 plus 15, which equals 30. So you do 50 minus 30, you get 20. So it's a little bit disorganized here because I've got limited room. So 20 euro is your profit if you sell 10 cakes. So 25 cakes, same thing. You're going to do R25 minus C25. So R25 is 5 times 25, which equals 125. C25 equals 1.5 times 25 plus 15. So let's do that. 1.5 times 25 plus 15 gives you 52.50. So 52 euro 50 cents. So your profit is 125 minus 52.50. Yeah, on your calculator you can do 125 minus, and then go second function answer, and that'll be 72 euro 50 cents. That's your profit for selling 25 cakes.